calculus grade 12. So in differential calculus for grade 12 learners, we need to know how to differentiate something like this. Now the big idea here is that pi is just a number, and yeah, this kind of looks funny, so getting dy over dx for this expression using the power rule is something that we definitely need to know how to do, and we're going to showcase that in this tutorial. Hi guys, Levi here from Bright Young Brains. So with a question like this one, if you're going to get dy over dx, you definitely need to simplify first. Now that's like the rule of thumb for all differential calculus kind of questions that need you to differentiate. You always need to simplify first. That's like the rule of thumb. So us simplifying this expression, clearly the one thing to point out is that pi is just a number. Don't think of pi as a variable, you know. And the other thing is, if you're going to get dy over dx, you need to focus on x. You see, anything that's not x, look at it as a constant, or in some cases it will be a coefficient. But anyways, simplifying this, right, what we need to deal with is these negative symbols here. These are kind of a problem. Now the best way to deal with these negative symbols is to remember that anything that's to the power of a negative, all you do is you want to consider the value that's in front of this whole thing here. Like the value that's in front of this whole bracket is just a 1, you see. So what you want to do is, as long as this is to the power of a negative exponent, if you don't want that negative exponent, which we don't, what you want to do is you basically want to take this under this coefficient in front there. Okay, so we have somewhat broken down this part. Now you may be thinking to yourself, why have we done that when eventually we need to differentiate? Now the funny thing is, for an expression like this one, you may want to visualize this like this first, because here you may want to do the exact same thing. Here we know that there's a 1 there. Here we also know that there's a 1 there. So what you want to do is this whole thing, you want to take it under the 1, and then this you want to take it under the 1 as well. Now the funny thing here is, if you look at what we have done here, I mean, if you're going to try and get dy over dx, it looks like it's a bit of a mess. So now that we have simplified this and that, what you want to recognize is that this bracket has an LCD of just x times pi. Now the funny thing is, if we get an LCD in there, let's see what that's going to look like. So the 1 over x, we're clearly going to need to multiply it by pi over pi. The 1 over pi, we can multiply it by x over x. So this simplified just looks like that. Whew. Okay, so it seems to be going down. So here, luckily they both have the exact same denominator now. So this here, we can write it like that. And I hope here you can already see the method to the madness. You see, because when you're multiplying fractions, right, remember it's the top here times the top there, the bottom here times the bottom there. So that simplified would just look like that. Now what you want to recognize is the fact that anytime you have something at the top here that's identical to something at the bottom there, you know, you can always cancel out. The reason why we can cancel out is that here we're plusing, you see. So these two could be swapped around, these two could be swapped around, and that would be exactly the same thing. So here, this can cancel that. Having to have done that, we know that y is equal to 1 over pi x. Now this we can differentiate using the power rule. The reason why we can differentiate this using the power rule is because we know that our exponent there is just a 1, which we need to deal with. You see, this here we have to simplify it some more for us to use the power rule. But what we want to be able to see here is that the exponent there is just a 1. Now we need to consider this 1 over pi here as our coefficient, and then this thing here we have to take it next to that value and write this as a negative exponent. So to do that, this is what our expression is going to look like. Remember, we haven't differentiated, we have just simplified. All we have done here is that this x here to the power of 1, because it's under the division line, what you have to do is you have to take it out and write it next to your fraction. This over that will be a coefficient. You see, this over that is our coefficient, x to the power of -1 there. Here we can clearly see our base and our exponent, which allows us to use the power rule, of which the power rule basically states now if we're going to differentiate, we need to remember that -1 times 1 over pi is the first thing that we have to do. -1 times the coefficient is just -1 over pi there with a negative. And then our power rule tells us that we have to remove 1 from the exponent. There we go. So here you are literally 80% done, because the idea is that your questions will always require you to leave your answers with positive exponents. So this here, if you're going to write it as a positive exponent, you have to now take it back down to where this pi is, and then you write it as pi to the power of, and then you write it as x to the power of 2. So here, this is going to be your final answer. Now, for more tutorials like this, you can subscribe to the channel. If you want tutorials on like a specific topic, you can just go to the playlists tab, and then you'll be able to see your different topics arranged into different playlists. If this tutorial was helpful, be sure to give it a thumbs up, and I will see you in the next video.